Okay, hello everyone. Today we're going to learn lesson 3-4, which involves graphing functions. So the homework that goes with this lesson is on pages 118 to 119, and we're going to do 2 through 22 even. Most of these homework problems do require graphing. I think there's only 2 problems on the assignment that don't require graphing. So you're going to have to be a little bit patient with it because those graphs take a little bit more time, a little more time-consuming effort on these problems. You're definitely going to want to do this assignment on graph paper or it's going to get really messy really quickly. So the first thing that you're going to be asked to do in your assignment today is you're going to be given a function and you're going to be asked to graph that function for a given domain. So hopefully what we've picked up over the last 2 lessons is that we understand that domain is your inputs or your x values. So if in the problem they've given you a domain, they specifically want you to use these x values in your problem. So today we're going to make our graphs by creating a table first, and then the points we get from our table are exactly the points that we're going to put on our graph. So if they're telling me my domain is 1, 2, 3, and 4, I'm going to put those as my x values, and then I'm just going to evaluate this function 4 separate times by substituting in those numbers for x. So in other words, in the first row, I'm going to do 3 times 1 plus 2, which is 5. I'm going to do 3 times 2 plus 2, which is going to give me 8. 3 times 3 plus 2 would give me 11, and 3 times 4 plus 2 would give me 14. So all we're doing is substituting these numbers in for x and working out the problem. So what we can do then is we can think of these 4 rows of my table as like 4 ordered pairs. They're just x and y coordinates. So this is what we're going to graph on our graph. So I'm going to put a point at 1, 5, at 2, 8, at 3, 11, and at 4, 14. And with functions like this, we're going to go ahead and connect the points because they're all today going to either line up or form some sort of pretty clear pattern. And then this question, just as a good review, kind of asks us, is this equation a function or not? So with the rules we learned about tables and graphs, we can tell that this is a function. So I'm going to say yes here because none of the x values are repeated, so that gives away from the table that it's a function. And then also with our graphs, we can do the vertical line test, and this would pass the vertical line test. So this is a function. So good review of vertical line tests. Let's give these a try. If I were to pass a vertical line across this, I would never hit in more than one place at the same time. So I would say yes, this is a function. It passes the vertical line test. But this one, if I were to draw a vertical line in several of the places here, I could easily hit more than one spot on that graph at the same time. So no, this is not a function. It fails the vertical line test. And this one is a yes, it passes the vertical line test. So on problems where they specifically give you a domain and ask you to graph it, those are the specific x values that should be in your table, and those should match up with the points on your graph. So we're going to go ahead and flip to the extra note side of things then, because in some of the problems, they're going to ask you to graph, and they're not going to give you a specific domain because they're considering the domain could be all real numbers. Well, we don't want to use just any and all real numbers because we don't want to end up with graphs that are huge. So if we take a look at what your directions are going to look like for these problems, here's how you know to do what I'm about to show you. If you look at the directions and all it says is graph each function with no other specific directives, then this is when you want to do what we're going to talk about. These 2 equations just came straight out of your book off of page 115, and we're going to graph these. And the way we're going to graph them is just like how the front gave you a table of values, we're going to make a table of values. So we're going to make an x and a y table. And we get to choose the values for x, but I'm going to ask that you kind of choose small, easy numbers for x, and we want a good representation of what this graph is going to look like across the board. So we're going to choose a couple of negative numbers, like -2 and -1, 0, 1, and 2. because this gives us a good idea of what the negative side of the graph will look like, what the positive side of the graph will look like, and then 0 is just our best friend because it's an easy number to plug into anything. So if I were you, I would use these 5 numbers pretty much all the time so that you don't end up with gigantic graphs that are going to take up a whole sheet of paper, and you have pretty easy numbers to work with. So I really want to look at the negative sign in this example because it's real easy to make a simple mistake with this right off the bat. The negative sign that's in that equation is going to stay there. So that negative sign from the equation stays, and I'm going to plug in a -2 for x so that this is the work I'm doing when I substitute in a -2. So I get that some people's initial reaction is like, ooh, a negative and a negative, that makes a positive. Okay, true, but in this case, order of operations would say we have to do the exponent first. So forget this negative sign for a moment and just think, what's -2 to the second power, which is -2 times -2. That's +4. But even though this is +4, this negative sign still remains. So your answer is going to be -4, and that's what needs to go in the table. Okay, so we're going to do that repetitively. This time, we're going to plug in a -1. So even if we do -1 squared and forget this, -1 squared is +1. But that negative sign remains, and we get -1. Okay, now 0, technically, yes, we're putting this in as -0 squared, okay, but negative signs also kind of mean the opposite of. 0 squared is 0, but we're not going to say -0 because the opposite of 0 doesn't exist. The opposite of 0 is just 0, no negative signs. Then we're going to do this with the 1. So I'm plugging 1 into my parentheses, and 1 squared is 1, but that negative sign remains, so -1. And then we're going to plug in negative with 2 squared in parentheses, so 2 squared is 4, but it will be -4 because of the negative sign in front. So we're going to notice that there is a pattern with these numbers, but it's not that type of pattern that we're used to that lines up right in a row. So when I'm drawing my graphs for these, I usually try to look at my table to know how big I need to make my x and y axis. Your x axis doesn't have to be very large. It just has to be big enough to stretch from -2 to +2. Your y axis needs to go down low enough that you can hit -4. So I'm going to draw kind of a short x-axis going this direction. And I'm going to draw a y-axis that goes down a few here. So here's my x and y axis. And I'm just going to number these a little bit out in each direction. So here's my x-axis, -2 through +2. I need to go down the y-axis down to at least -4. You can go further if you want. But this should cover what I need to graph on my grid. So we're going to graph these ordered pairs. -2, -4 would be down here in the lower left quadrant. Here's -1, -1. 0, 0 is right there on the origin. And then we're going to notice a trend where we go back down. 1, -1 is here, and 2, -4 is here. So we would connect that with kind of a curve, not a pointy pattern. And this is something we'll come up with later in the year when we graph quadratics and we learn that these have a name called parabolas. But basically the reason this pattern happened is because we had an x squared in our problem instead of just an x. So we're not worried about understanding parabolas and quadratics and all that at this point. You could graph any equation they ask if you just understand how to make a table of values. So this is our focus for today. If we understand that we can plug in any value for x and find a matching value for y, we can graph anything regardless of what it comes out to look like. So this is our goal for today. We're going to go ahead and try it one more time with something that's a little more familiar to you guys. Y equals -4x plus 2. We're going to make our table of values with an x and a y column. We're going to pick those small, easy numbers of -2, -1, 0, 1, and 2. And this one we can probably do pretty mentally. You're welcome to write it down if you need to. But I think most of us can substitute that -2 in there mentally and say -4 times -2 would be +8. And then if we add 2, that would be 10. If I substitute in -1, -4 times -1 is 4. If I add 2, that's 6. If I substitute in a 0, -4 times 0 is 0. Add 2, that's 2. Plug in a 1. Negative 4 times 1 is negative 4. So be cautious with your negatives. Negative 4 plus 2 would be negative 2. And then if we plug in a 2 here, negative 4 times 2 is negative 8. And if we add 2, that would be negative 6. So on this one, my x-axis still has really small numbers, but this goes up to 10, down to negative 6. So if you get something that you feel like is going to be an overly large graph, you could always count by 2s. So that's what I'm going to do on this one, just to make myself not have to go quite as far on my grid. I've got an x and a y-axis here. And I'm going to number each grid mark as 2, like 2, 4, 6. And they need to go in each direction. And we need to make sure on the y-axis we get up high enough to hit 10. And we get down low enough to hit our negative 6. So the table kind of reveals how big of a grid you need to draw. So I'm going to graph these. Negative 2, 10. It's up here. We just have to be okay with if we count by 2s and we have an odd number like negative 1, it's not going to be right on the line. Negative 1 would be right here, and I would go up to 6. So here's negative 1, 6. Then I have 0, 2. Okay, again, here's an odd number. I have 1, negative 2. So over 1 would be here, and down to negative 2 would be right there. And then 2, negative 6. And I'm going to go ahead and connect this. Okay, so the one thing that those your turn examples didn't give us a chance to practice is if our equation has a fraction in it, it has the potential to get really messy. But if we choose numbers wisely, we can avoid a mess of a problem. So this is why I chose another example off page 118 to do. Just kind of picked a random function off of page 118. And this one we're going to graph as well because it gives us practice with this fraction of 1/3. So, as I recommended in the problems above, I say stay as small as you can with the numbers you choose to put in the table, and I would almost always go with negative 2, negative 1, 0, 1, and 2. This is an exception though. If you have a fraction in your problem, okay, we talked about the phrase work smarter, not harder in class today. Because this fraction has a denominator of 3, if I use multiples of the denominator for x, I am going to save myself a lot of trouble. So by multiples of the denominator, this one would mean multiples of 3. If your denominator was 4, you would use multiples of 4. If your denominator was 2, you would use multiples of 2. So the multiples of 3 that I'm going to use are negative 6, negative 3, 0, 3, and 6. So I'm going to zoom in real tight so that my work doesn't look so tiny, and I'm going to show step by step exactly what's going to happen when I plug negative 6 into this. I'm going to write down 1/3, and then where I substitute in for x, I'm going to plug negative 6 in parentheses, but I'm going to make it say negative 6 over 1, and then I have minus 2 after that. So here is where we said we're working very smart right now. If this is 1/3 and I multiply it by negative 6, the number in the denominator and the number in the numerator are multiples of each other, which means we can cross cancel. And if I divide by 3, I can make this a 1, and I can turn this into a negative 2. So I have made this just have 1s on the bottom. It's no longer a fraction. That 3 on the bottom is gone. Basically, I'm doing 1 times negative 2, which is negative 2. And then don't forget that we need to subtract 2 to finish out the rest of the problem. So negative 2 minus 2 is negative 4. Okay, I'm going to do it again a little more quickly. 1/3. I'm going to substitute in negative 3 over 1. And don't forget the minus 2. My 3's are going to cross cancel. So I basically have 1 times negative 1, which is negative 1. And then make sure you subtract 2, which is negative 3. Okay, again, 0 is our best friend because if we do 1/3 times 0, that's just 0. And we know 0 minus 2 is negative 2. So there's an easy one. And then we're going to repeat it with the positives. So 1/3 times 3 over 1 minus 2. I would cancel out the 3's, making 1 times 1 is 1. Don't forget to do minus 2. 1 minus 2, negative 1. And last but not least, 1/3 times 6. Your 3 and 6 are going to cross cancel, leaving you with 2 minus 2, which is 0. So now we have a nice, easy table to graph without a mess of fractions that we're trying to figure out how to put on a grid. So I'm going to zoom out and graph that real quick, and then we'll talk about the last two concepts. So in this one, my x-axis needs to stretch from -6 to 6. But then on the y-axis, I need to make sure I go down to at least -4. So 1, 2, 3, 4, 5, 6. Do the negative side. And I'm going to graph that real quick. -6, -4, -3, -3, 0, -2, 3, -1, and 6, 0. Okay, so many problems today will ask you to make they won't say make a table and graph, but when they just say graph it, you know to make a table using wise numbers to make that as easy as possible on yourself. All right, so these last two sections that we're going to add, okay, there's going to be mention of using graphing calculators in the directions for the homework. And I just want to make sure that I show that yes, the graphing calculators can do some really cool things and could be used for these, but you can definitely do the work without having a graphing calculator. So just to be clear, no excuse for not doing problems because, oh, it said use a graphing calculator, because we're going to show right here that you can totally do it without a graphing calculator. So we're going to take a look. I'm going to zoom in here. And we're going to look at some problems off of page 115 and 116. And here is kind of what I'm saying. They're going to talk about using a graph to find some values. And so if you look at the example in the book, okay, they show it as, oh cool, we graphed this function on our calculator, and then in the calculator we can see on the graph what's the value of the function when x equals -2. So the calculator has some cool tricks that we kind of looked at in class a little bit, and those are useful. But when we don't have a graphing calculator and you have problems where you're given a function and it says find the value of this when x equals -2, we're going to show you the way to do it by hand. If you see something that says find the value of f of x when x equals -2, you know what you do? You make the x equal -2. So if you were doing this by hand on homework instead of with a graphing calculator, you would simply plug in a -2 for x. So this would say f of -2 equals -1/2 times -2 plus 3, and we would just work it out. So we don't do anything with this f of -2, it just stays f of -2. But then we multiply. -1/2 times -2 is +1. And 1 plus 3 is 4. So the value of this function when x equals -2 is 4. And we did that just fine without a graphing calculator. Let's do it one more time. If we graphed this, that would be cool, but we can do what's the value when x equals 2 without needing to graph it. All we got to do is plug in a -2. So 3 over 2 times -2, I'm going to put -2 over 1 minus 4, because this is kind of that same idea with our last table that had fractions in it. If I want to multiply these, I'm just going to cross cancel. The 2's are going to cancel each other out. So it's basically 3 times -1. So -3 minus 4. I'm going to get f of -2 equals -7. So I think it's problems 10 and 12, I believe, on the homework that are like this. So when you see directions that talk about finding the value when x equals this work will be just fine. You don't need a calculator to do it. So you don't have to graph those. You can find the value without ever needing to graph it. Okay, last thing we want to take a look at. On page 117, there is a word problem that I want to read through with you, and then we'll talk about how we would show the work to appropriately answer this. Here is our problem right here. It says a cruise ship is currently 5 kilometers away from its port and is traveling away from the port at 15 kilometers per hour. The function y equals 15x plus 5 relates the number of kilometers y the ship will be from the port x hours from now. Graph the function and use the graph to determine how far the cruise ship will be from its port 2.5 hours from now. So first thing, here's the function, and they want us to graph it. So my recommendation is, since for all the graphs we did earlier, we made a table, I say we make a table. Okay, now in this table, it wouldn't make sense to do negative values because x is the number of hours that the ship has been traveling. So we don't need to go back in time. We're not going to go negative hours before the travel ever started. So I would say starting with like maybe 0, 1, 2, 3 would be acceptable for this. So if we were to plug in a 0 right here, 15 times 0 plus 5 is 5. If I plugged in a 1, 15 times 1 plus 5 is 20. If I plugged in a 2, 15 times 2 plus 5 is 35. And if I plugged in a 3, 15 times 3 plus 5 is 50. So we could represent that with a relatively small graph here where we do 1, 2, and 3 hours. And then maybe count by tens, like 10, 20, 30, 40, 50. This is kilometers that the ship has traveled. And we could say 0, 5, 120, 235, and 350. And we've kind of plotted out what's happening with the ship here. Okay, and then the final part of that question says to figure out how far the cruise ship will be from its port 2.5 hours from now. So this is where having the table and the graph are useful. You can see that 2.5 hours would fall halfway in between hours 2 and 3. And look on your table. That would be 2.5 would fall right here halfway in between the 30 and the 50. So what we kind of discussed in class is you would need to basically find what would come right in the middle of 35 and 50. And we said the easiest way to do that is find the average. So we kind of reviewed finding averages. To find an average, you would add those two numbers together, 35 plus 50, and you would divide by 2. So that ends up coming out as 85 divided by 2, which is 42.5 kilometers. So even though that exact number is not on your table or on your graph, having clear points for what was 2 hours and what was 3 hours can help you find what 2.5 hours was. So like I said, again, in class we will play around with the graphing calculators and learn some cool tricks with this, but we just want to make sure that we're okay with the idea that just because there's mention of graphing calculators, this was not an assignment that required it. So basically on this homework assignment, you should be graphing almost every single problem except 10 and 12 that talk about this type of situation where you could do that without a graph or without a calculator. And that's kind of our goal for today. Thank you.